All right, guys, this is the start of Unit 7. So Unit 7 is our organic chemistry unit. So this first video is going to be looking at how organic compounds are classified and a little bit of an introduction to organic chemistry. Again, I'll post these blank notes for you guys afterwards, so it's a little bit easier for you. So let's start by looking at what organic chemistry is. So it is the study of carbon compounds. We're going to abbreviate compounds like this. All right, so carbon bonds in various ways. This can be a chain, a ring, or a network, and we're going to look at these further along. For the most part, these guys are nonpolar molecules. Remember, when I say nonpolar molecule, I'm looking at the symmetry or the shape, right? So they're symmetrical if they're nonpolar. They have low boiling points and melting points. Let me just fix that. Low boiling and melting points. They're poor conductors of both heat and electricity. And they react slowly. All right, so the takeaways for organic compounds, so they're carbon compounds, they're nonpolar, so they're symmetrical, low boiling and melting points, they're poor conductors, and they react slowly. So carbon, we know, has 4 valence electrons, so that's going to look at the bonding. So carbon usually has 4 bonds, so 4 valence electrons in carbon. So it forms 4 bonds, right? This leads us to a stable compound. But we can also have single bonds, double bonds, as well as triple bonds with these organic compounds. Right, so if you look up here at the top with this little diagram I have, we have our single bond here, circled in yellow, our double in green, and our triple in red, just to show different configurations. Right, so these are all different ways for them to become stable. There is a key term that we're going to look at a little bit further down the line, but with the double and triple bonds, we call these unsaturated. So a little bit different than saturation as we talked about with solutions, but just keep in mind double and triple bonds are considered unsaturated. All right, so with our organic compounds, we like to refer to these guys as hydrocarbons. So they only contain, I'm sure you could guess from the name hydrocarbons, they only contain hydrogens and carbon. Right, so they are a homologous series of hydrocarbons. There are homologous series, hydrocarbons, and there's 3 of them. So they're all considered similar compounds, so that's what this means. So similar compounds, and there's 3 of them. We're going to talk about all 3 in this first video. So our first one is alkanes. Our second is alkenes, and our third is alkynes, right? So we have our differences here. We have anes, enes, and ines. There should be no N here, so we'll get rid of that. So those are our 3 homologous series. So we're going to talk about the differences between each of them, how we name them, how we figure out what they are, all right? So let's look at our first one, which is our alkanes. So these only contain carbon to carbon single bonds. So single alkanes are only single bonds, right? These are considered saturated compounds. And the way this compound is written out is CN, H2N plus 2, and N is our number of carbon atoms. So on our next slide, we're going to look at how we name them, kind of using this little formula for it. So luckily for us, in your reference table, where's my reference table? In your reference table, this is going to be table P. It's on page 7 in your reference table. So we have table P, page 7. Okay, so when we name our alkanes, let's just write the formula up here again. CnH2n plus 1, plus 2. I'm sorry, plus 2, not plus 1. Plus 2. Okay, so our first example here, we're going to have CH4. So we look at our carbons. We have 1 carbon. So we're going to go over to our table and see, okay, 1 carbon atom, our prefix is meth. And then the endings of all of our alkanes are going to follow along. So it's going to be methane. Right? So when we name it, it's going to be our prefix plus ANE. Right? So if we look at this again in another example, we're going to do C4H10. So we have 4 carbons here, so we're going to find 4 on our table, so bute. Bute is our prefix. So we're going to do bute plus ane, and we end up with butane. Right? So this is how we're naming our alkanes. Prefix plus ane. Again, this table is table P on page 7 in your reference table. So let's look at our structural formulas. So these show how the atoms are bonded. All right, so, sorry, I had to see what my next slide was. So let's look at methane again. So CH4. We've drawn these before with our Lewis diagrams and when we talked about naming and drawing structures and using the dashes. So we're going to start with our central carbon. And we know that it has 4 valence electrons and that it has 4 hydrogens. So we're just going to set it up like we would in the past with other compounds we've built. Right? So just to show it again, we're going to look at a different one. We're going to look at C2H6. And what we're working with here is this is ethane. I'll write the name just so you guys can see it. Ethane. So we had 2 carbons. So I looked at table P and the prefix was F and I added ANE to the end. So we have 2 carbons. So we're going to set our 2 carbons up first. And then we see that we need 6 hydrogens. So 1, 2, 3, 4, 5, 6. And we'll add our H's in here. Right, and if you notice, it's starting to get linear, right? This was one of the shapes we started talking about earlier that I mentioned. So let's look at one more example. We're going to do C3H8, which according to our table, this is going to be propane. So again, we'll set up our carbons, 1, 2, 3, and we need 8 hydrogens total. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then we'll add our H's in place here. So very similar to how we've drawn and sketched our compounds before. We're just working with hydrogen and carbon. So those were our structural formulas. Now we're going to look at our condensed structural formulas. Sorry, a little tongue-tied this morning. So our condensed structural formulas. So our central atoms and the atoms connected to them are written as a group to represent the structural formula. So it's going to look a little bit different than the ones we just drew. That's why they're called condensed. It's to save us a little time with drawing the structures. So we're going to write them as groups. So let me just check my next slide, make sure I don't have a separate one. Okay, so our condensed structural formulas. So we started with methane, right? Let's change the pen color. So CH4 was methane. We drew it out, our structural, with a carbon and our 4 hydrogens, right? Our condensed structure is going to be just CH4, right? And then we're going to look at C2H6. We would write CH3 because that's how our structural formula was drawn, right? We had C with 3 H's, and then we had C with 3 H's on the side. So we're just condensing everybody. It's in the name. So if we look at C3H8, I'm not going to draw the structural formula for this, and we're just going to draw the condensed. We have CH3, CH2 in the middle, followed by CH3 on the side. All right, so we're just condensing. It makes it a little bit easier for us to draw. So what I would like you guys to do is take a few minutes, pause the video, all right, pause the video, and try to work on these guys. I'm going to keep going with my recording and fill these in just so I don't lose time, but please give these a go on your own, kind of as a practice, and then check yourselves. So, heptane. Now we're going from the name to the formula. So you're going to need table P in your reference table. Again, that's on page 7. So hept is our prefix for 7. So I know I'm going to have 7 carbons, right? And our formula, again, was CnH2n plus 2. Right? So if I have 7 carbons, 7 times 2 is 14. I'm going to have 16 H's. So my structural formula is going to be quite large, right? So we're going to have 1, 2, 3, 4, 5, 6, 7, and then, all these guys are going to be hydrogens. Just to save space and time, I'm not going to write the H's in. Just know that on the ends of all these dashes, there's H's. Right? I'll put them on the ends so we know. Okay, so our condensed formulas, we're going to kind of copy what we wrote here. So if we look here, I have a CH3. So my first one is going to be CH3. And then in the middle, I have 1, 2, 3, 4, 5 that are, hold on, let me change the pen color so it kind of goes together. So I have a CH3 on the end. And in the middle, I have 1, 2, 3, 4, 5 CH2s. So I'm going to do CH2. I'm going to write this 5 times. 1, 2, 3, 4, 5, and then again at the end, I have another CH3. So that's how writing out our condensed formulas go. So let's look at the next one, which is going to be butane, right? So butane is 4, but is 4, so we have C4, H4 times 2 is 8, plus 2 is 10, H10. So we have C1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, same thing with the condensed. We have a CH3 on the end. We have 1, 2 CH2s in the middle, CH2, CH2, and then we have another CH3 on the end. So you guys can start to see the pattern and how it's going along the way. So pentane. Pent is our prefix for 5, so we're going to have C5H12. And we're going to have 5 carbons now. So 1, 2, 3, 4, 5, with our 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens around there. And again, our condensed is going to be the breakdown. 1, 2, 3. Okay, and our last one, octane. So oct is the prefix for 8. So we're going to have C8H8 8 times 2 is 16 plus 2 is 18. So this one's going to be kind of long. 1, 2, 3, 4, 5, 6, 7, 8 with all of our hydrogens. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then we have our CH3. And then we have 1, 2, 3, 4, 5, 6 CH2s. So 1, 2, 3, 4, 5, 6, followed by our CH3 to end it off. I'm just going to write it on the bottom since I ran out of room there. All right, so structural formulas, condensed formulas. They're just two different ways to show the formula broken out as a chain. So that's alkanes with an A-N-E, all right? Now we're going to look at alkenes. The difference here is the ending. So these contain a carbon-carbon double bond, right? Our alkanes were single bonds, so our contained a carbon-carbon double bond. Okay, and they are unsaturated. And our formula here is going to be CnH2n. And remember that N is our number of carbons. Okay, same concept with the naming. We're going to use table P for our prefixes. So table P, page 7. And the only difference here is our naming is going to be prefix plus E-N-E at the end, ene. Okay, so if we have C2H4, we're going to look for that prefix that is 2, which we know is F. So our name is going to be ethene, okay? And then we have our next example, which is going to be C3H6. We're going to look for that 3, which is going to be prop. So we have prop. And then we're going to add our ending of ene, propene. Okay, same idea as naming the alkanes. We're just changing the ending. And the formula, CnH2n, is different as well. So, structural and condensed formulas, same idea, except now we're going to have double bonds. All right, and we're going to have numbers that tell us where to put the double bonds. So we're going to start with propene, and we said that this was C3H6. So there's only 2 spots our double bonds can go with here. So I'm going to put it on my first carbon. So a double bond is going to be 2 lines, and I have 3 carbons, which means I'm going to have 1, 2, 3, 4, 5, 6 hydrogens. Remember, everybody needs to have that stable octet. 8 is great. So where we have the double bonds, the distributions of hydrogen is going to be a little bit different. So that's our structural formula, and our condensed formula is going to be CH2, CH, CH3. So this one's going to be a little bit different. So now we're going to look at one that comes with a number. All right, so our first, let me just check my next slide. Okay, our first one, let's look at 2-butene. Okay, so this number 2 with the dash, this is the location of the double bond. So what this is saying is that our double bond is going to be on the second carbon. And I'll talk about how we count those in a second. So butene is C4H8. So we're going to have 1, 2, 3, 4 carbons. Our double bond we said was on 2. So I'm going to count 1, 2, and I'm going to put my double bond between the second and third carbon. This is going to be 3, and this is going to be 4. So the rest of our guy is going to look like this. And then we're going to spread out our hydrogens so we have full 8 on everybody. Again, I'm not going to write the H's. At the end of those dashes exists an H just to save time and space. So what that means is our condensed formula is going to be CH3, CH, CH, CH3. So the number is important. That's going to tell us where those carbons go. But there's a certain way we need to count. So the parent chain is your carbons in the middle. This is your parent chain. So when we're counting, we're going to count the carbons, the carbon parent chain, from the side closest to the double or single bond. Chain from the side closest to the double or triple bond. So with butene, it didn't matter because there were 4 carbons, so there was 1 right in the middle. But if we look at something with an odd number, 1-pentene. So remember, pentene is 5, so you see C5H10. We're going to have 1, 2, 3, 4, 5 carbons. So I can put my double bond here, or I could put my double bond here, depending on which way I count. If my double bond is the green, that means this is carbon 1. If my double bond is the blue, that means this is carbon 1. So we're going to keep it with the blue, and we're just going to fill in the rest. So 1, 2, 3, 4, 5. And then let me just erase this one. And then we're going to put our hydrogens in. So we're going to have 1, 2, 3, 1, 2, 1, 2, 1, 2, 3. All right. So with the counting, just keep in mind that your first carbon is going to be the carbon that is closest to the double or triple bond. Now we're going to go into our triple bonds. So alkynes. So YNE. This is our third type. And these are carbon triple bonds. Again, these are unsaturated. And our formula for this one is going to be CnH2n minus 2. So a little bit different than the other two. We're subtracting 2 hydrogens now. So let's quickly look at naming alkenes. Again, same concept, table P, page 7. Only difference with this one is we're going to have prefix plus YNE. So remember our formula, CnH2n minus 2. So let's look at an example here. So let's do C2H2. So we look for our prefix for 2, F. So we're going to have F with our ending -ene. Okay? Same concept as alkanes. Alkenes, we're just changing the ending. So let's look at one more before we move on to structural formula. So C3H4. We're going to look for 3. 3 is prop. So we're going to do prop plus our ending of -ene, propene, propine. You can pronounce it either way. I'm not going to spend too much time on naming. It's the same concept as alkanes and alkenes. But we're going to talk quickly about the structural and condensed formulas. So, same thing. If you see a number, that's where the triple bond is. Okay, so let's look at ethene. So we had C2H2. So let's start by building our parent chain. And since we only have 2, there's no number. We know that the triple bond exists right smack in the middle. And we only need 2 hydrogens. So our condensed formula for this would be CH. Okay, let's look at one with a number. Let's look at 3-heptine. So heptine, hept we said was 7. So we're going to have C7H12 for this one. So let's start building our parent chain. So we have 1, 2, 3, 4, 5, 6, 7. And it says that our triple bond is at 3. So what I'm going to do is I'm going to start from the left-hand side. This is going to be carbon 1, 2, 3, 4, 5, 6, 7. So 3, I'm going to put my carbon, my triple bond between the 3rd and 4th carbon. I'm going to fill in the rest of my carbon-carbon bonds. Make this one a little bit longer. And then I'm going to distribute my hydrogen. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice that our carbons in the middle don't have a hydrogen bond, right? because they already have their 4 bonds, 3 that they share and then 1 that they share with the carbon next to them. So what does our condensed formula look like for this? So we have CH3, CH2, C, C, CH2, CH2, and CH3. So remember our condensed formulas, where instead of drawing out each line, we're just writing the abbreviation of each part. All right, I know this went kind of quickly, but please take your time. When you watch the videos, pause it, take notes. I'll post the blank copies of the PowerPoint for you guys as well. So what I would like you guys to do at the completion of this video is in Google Classroom, there are a couple multiple choice sheets for you guys to do. I'm going to upload them as Google Forms so that the answers are graded right away for you guys. So video 1, that's this video, lesson 1. It'll be up in Google Classroom with the questions that I would like for you guys to complete. If you have any questions, you know how to reach me, and keep an eye out for lesson 2. We'll talk about due dates once they're posted, and I'll write about it in Classroom. All right, guys, keep doing what you're doing. You're doing great so far with this remote learning. I honestly am very proud of all of you. Please, any questions, you know how to reach me. Stay in touch. Keep doing what you're doing. All right, keep an eye out for the next video.